Good day once again, students. We are going to continue with the second video on answering questions in moles. Answering questions in moles, the Edexcel curriculum. Of course, it can be useful to students from other curriculums too. Now, number 20, 100 cm cube of hydrogen is mixed with 25 cm cube of oxygen at room temperature at 150 degrees centigrade. At a temperature of 150 degrees centigrade, the gases react as shown. This is the reaction of the gases. Now, when you look at this equation, it is actually a balanced equation. So we have ratio of 2 of hydrogen to 1 of oxygen to 2 of steam produced. Now, what is the question now? The total volume of gas present at the end of the reaction. Not the total volume of gas produced, the total present. When they say the total produced, you are only concerned with the one on this side of the equation. But when they say the total present, what you should consider is there any excess from this side? You write that excess down first. Then you now add it to the amount produced. Again, when you are asked for the volume produced at the end, only this is involved. But in this question, they are not asking for the volume produced. They are asking for volume of gas present at the end. Volume present at the end means the volume that did not react plus the volume that is produced. So now, let us now look at the volume that did not react and volume that it produced. That means volume present equals to volume produced plus unreacted volume. Volume present at end of reaction equals to volume produced plus volume unreacted. That is the unreacted volume. So what is the volume produced first, or volume unreacted? Let's look at it. We get this, we get this. So 100 cm cube of hydrogen is mixed with 25 cm cube of oxygen at room temperature. 100 of this is mixed. 100 of this, we need 25 of this according to the equation, but 25 of this is not present. How many is present? We need 100 of this, we need 50 of this. Actually, 100 of this according to the equation, 2 to 1. 2 to 1 ratio. 100 cm cube of this should need 50 of this, but 50 of this is not present. So what that means, oxygen is limiting. It is limiting. It is not enough. Limiting means the one that is not enough. So I only have 25 of these. That means even if I have 1 million of these, this guy will only take 2 multiplied by 25 because it's ratio 2 to 1. So this has to be 50 reacting. So the amount of this reacting will be 50, not 100 that you are giving. We are giving 100. Only 50 of these will react because only 25 of oxygen is available. It's supposed to be 50 that you react, but only 25 is present. What do? Nothing. It will only take what it can take from the 100. It takes 50. That means volume unreacted, we already have 50 cm cube of what? Of hydrogen. Good. 25, everything here reacted. So volume unreacted now, we are sure is 50 cm cube of hydrogen that did not react, because out of the 100, we have 50 reacting. How much of steam will be produced? 2 here, because the amount of this reacted will be the amount of this produced, because they are the same ratio. So I have 50 cm cube. So how much is volume produced is 50 cm cube, because only one thing is produced. So 50 plus 50 gives me 100. 50 plus 50 gives me 100. I always have to check for the answer because I pre-solved this question earlier before solving it on the board, so that it will be very fast for us. We don't have to make mistakes. We don't have to make too much mistakes. The benefit is for you to understand. So we are correct. We get 100. Volume at the end is 100. So because, as we have seen, this used, this produced, out of 100, we have 50 more. So 50 produce, 50 left. So that is 100. Next question. Hydrogen and oxygen react according to the following equation. Again, if volumes are measured at this and 1 atmospheric pressure, this they don't really concern you too much. The volume of steam produced, that means all of them are the same pressure and temperature. The volume of steam produced after 50 cm cube of hydrogen. So first we also have ratio 2:1 to produce 2. Similar question. Now, if all volumes were measured like that and the volume of steam that will be produced, how much of this was given to you? 50 cm cube of hydrogen was given to you. React completely with 25 cm cube. Of course, 50 we need 25, of course, and you have given the 25. It's not a big deal now. You don't have any problem now because you need 25 and 25 is given to you. So, what are they asking? They are asking the volume of steam produced after. They are not asking for the volume of gas at the end of reaction. They are asking for the volume of steam produced. Or they may say the volume of the product. So the volume of the product will be, of course, the volume of this, because it's 2 here and 2 here. If this is 50, 25, this will be 50 because it's 2. So volume of steam produced is 50 cm cube. And that's option B. I will check if we are correct from my this here. Option number B. Option number B is also correct. Let's move on. An important reaction which occurs in the catalytic converter of a car is this, of course. Very important reaction for green live. Now, in this reaction, when 500 cm cube of CO reacts with 500 cm cube of this, first get your ratio 2 of this, react with 2 of this, react with 2 of this, and 1 of these. Ratio 2:2 reacted, ratio 2:1 is produced. You can see the product, you can see the reaction. Then what next? In this reaction, 500 cm cube of CO reacts. 500 cm cube of these reacting with 500 cm cube of these. Of course, that means everything is going well. These of these, they are equal, and they are equal. What you are given is they are all equal at this temperature. Then they are saying, and pressure, total volume of gas produced at the same temperature and pressure will be what? This is quite easy. 2 to 2. This also is 2 also. This also 500, since it's the same ratio. And since this is half of the ratio, it will be 250. Again, they are asking you of volume of gas produced at the end. Volume of gases produced at the end. Sometimes they may trick you. What is the volume of carbon dioxide produced at the end? What is the volume of nitrogen produced at the end? But now, gases, that means both of them, because sometimes in the question they may ask for one, and you may be so much in a hurry, you write both. And that answer will also be there. There's multiple choice. They put foolish answer and wise answer. My students will always choose wise answer. Now, the volume of gases. This is a gas, this is a gas. Sometimes you have solid, sometimes you have liquid. They will say volume of gases produced. You have to look for the symbol, for these symbols to get which one they are looking for. You have to be very wise. So volume of gases, only 2 products and both of them are gases. 500 plus 250 are their volumes, and it gives me 750 cm cube. And I choose option B again, which is question number 22. Option B, am I correct? I'm also correct. Let's go to question number 23. We are moving. Calculate the mass of calcium hydroxide present in 100 cm cube of 0.1 mole per dm cube solution. And of course, we have been given that assume molar mass of calcium hydroxide is this per mole. That means every mole of that is this, which is we don't have to calculate Ca plus O2 times 2 plus. We don't have to do that again. It has been given to us. Sometimes we need to do that if this is not given. Now, what are we doing? We have been asked to calculate the mass of calcium present in this. For us to know the mass, we need to know the mole, because mole equals to mass divided by molar mass. So now, for us to know the mass, we need to say that this number of mole also is the same thing as saying we know number of mole as far as concentration is concerned. We have been given the concentration of the solution. We know concentration multiplied by volume in dm³, or we say volume divided by 1000. You say volume in cm³ divided by 1000, or you say volume in dm³ directly. You convert the volume first and you multiply by concentration. Or many of you like to do it like this. This multiplied by this divided by 1000 is the same thing. Whatever method you know, you use it. Now, when we get this, we place it here, and we know the molar mass, we get our mass, and we can put it directly, and we get our answer. So this gives me, bringing this one here, mass we are looking for, mass divided by mr, 74, is equal to, this is 0.1 multiplied by volume. Am I giving the volume 100 divided by 1000? So I'm looking for mass. This is 74. That's 74. My answer is almost there now. I'm almost there. So mass is just this multiplied by 74. That multiplied by 74, that is quite easy for me. It becomes easy for me. So I just cross multiply there. I say mass is equals to this multiplied by that. 0.1 multiplied by 100 is 10. So 1, 2, 1, 2 or so. So 74 multiplied by 0.1 divided by 10. 74. Why do I keep writing 75? Am I 75 years old? No, I'm not that old. This times this is 7.4 divided by 10, and my answer is 0.74 grams. 0.74 gram. Look at it. Calculate the mass of calcium hydroxide. Calculate the mass of calcium hydroxide. Let me check if I got that. B, 23 again. 23. Oh, V, B. Always B, 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 B. I've chosen a lot of B questions here. You can see that. Now, let's go. The recommended limit of safe exposure to sulfur dioxide in air is this. Percent. What is the concentration in part per million? This is this percent. Let me first write that. Remember, part per million, you have a formula, ppm. ppm equals to component you are talking about, divided by mixture. You can see mass of component by mass of mixture, or volume of component, volume of mixture. Okay, multiply by 1 million. 1 million. So the answer will be in ppm. 1, 2, 3, 4, 5, 6, 7, 6 I need. Now, but what I have here, this divided by this means these. The whole of this is this, because they say the recommended limit of safe exposure, this is this percent. They didn't just give you a mass. Usually they give you a mass or volume or this, but they have given you in percentage. That means for this, it means, this means 0.00025 divided by 100. That's what it means. The component will now be 0.000025 divided by 100. That's what it means. 0.000123425 divided by 100. That's what that means, times 1 million. So I cancel 2, I cancel 2 0. So that means this multiplied by this will be how many 0? 1, 2, 3, 4. I move these 4 times, 4 places. 1, 2, 3, 4. This equals to ppm equals to 0.25. 0.25. That's 0.25. Let me check again. 1, 2, 3, 4. 1, 2, 3, 4. 0.25 ppm. B again. Question number 24. B again. The teacher has selected so many questions with a B. Don't pick B all. So I hope you understand this. Part per million is components, whether volume or mass of component divided by the total mixture multiplied by 1 million. That's part per million. Part per million then is 0.25. Let's go on. 25. When 0.6 0.35 grams of copper relative atomic mass. This is added to an excess of silver nitrate solution. This of silver has been produced. This amount of silver with relative mass this was formed. The ionic equation of the reaction is this. We were giving copper and we were giving copper, and copper solid reacted, and at the end of the day we achieved a solution and we also got silver as a solid. So that's what they are asking us to say this. So they are asking us, when this happened to an excess silver nitrate, this of silver was produced. We know the amount of silver that was produced, which is the amount of silver produced, which is 2.158 grams. And what is the amount of copper given to us? The amount of copper given to us was what? 0.635 of this, and it gave us this. So how much of mole of this did we use, and how many moles of this was produced? If you know the ratio of this to this in moles, then you'll be able to get it in the equation. Let's check that. This is 0.635 divided by relative atomic mass, or they say something per mole, is equals to 63.5. They have moved the zero how many times? 1, 2 times. So this is equals to 0.01 because 1, 2. So this divided by this is equals to 0.01, and this, it will be 2.15, which is mass. Of course, don't forget N equals to mass over molar mass. Okay, the same thing here. Mass of this is this, and the molar mass is given to you as 107.9. 215 divided by 109. 2.15 divided by 107.9. 107.9 gives us 0.019. 0.019999 is 0.02. 0.02 of this. 0.02 of this. That means 0.01 of this reacted, and 0.02 of this is formed. So what we are looking for now is that in our equation, copper should be 1 here, and this should be 2 here, because it is ratio 1 to 2. This should be 2 here. Is there anyone in the equation where we got copper solid at the beginning of the equation that is 1? Or this is 1. We can go for this. We can go for this. We can't go for this because copper is 2 there, and we can go for this also. So, but which of these 3 do we have silver solid to be 2? Only this one, and that means this is our first D answer. That shows D is our answer. And let me check that. 25 is also D. 25 is also D. We are definitely correct. Now let's go to 26. 26, a compound was analyzed and found to contain this of carbon, this of hydrogen, and this of nitrogen. These ones are so easy that sometimes I don't like solving them, because you have been doing this for donkey years. You have been doing this for donkey years. So somebody is saying 1.45 of carbon, of course, as usual, carbon, hydrogen, oxygen, carbon, hydrogen, oxygen as usual. Of carbon, 1.45. Of hydrogen, 0.4. H2, and of oxygen 1.69. So divide by 12, divide by 1, and divide by 16. Divide by 16. Divide by 16. Let me just do them. So this will be easy. 1.45 divided by 12. 1.45 divided by 12. 1.45 divided by 12. 1.45 divided by 12. And what do I get? 0.12, 0.12, 0.12 is as good as 0.1, 0.12, and this is 0.4, H2, and this 1.69 divided by 16, 1.69 divided by 16, 1.69 divided by 16, and that also gives me is 0.12. 0.12, 0.12, 0.12, 0.12, also 0.12. So divide by 0.12, which is the smallest, divide by 0.12, divide by 0.12. So this will be 1, this will be 1, and this is about 4. This is about 4. This is about 4. So I then have C, only 1. H, this is about 4. H, 4, and O, only 1. C, H, 4, O. And sorry, did I say O? Nitrogen. I'm really sorry. I've been using O since. Making a mistake. I have to. I made a mistake there. This is not 16. This is not 16. Oh, look at the teacher making a big mistake. Please correct it, please. You have to divide this one. We are wrong all along because we have been using oxygen, because this is a very common one. Carbon, nitrogen, and oxygen is a very common one. It's nitrogen. I'm sorry for that. This is this one divided by nitrogen is 14. We're even given there. So we go all over again. We got this here. 1.2 here. We got here 0.482. Mistake, big mistake. And this divided by 14, 1.69 divided by 14, 1.69 divided by 14. This was 0.12. Oh, 0.12. 1.69 divided by 14. 1.69 divided by 14 gives me 0.12 also. Lucky me. 0.12. This is 0.12 also. 0.12. So lucky me, I'm getting the same thing whether I use oxygen or nitrogen, because the numbers are small, and MR of oxygen and hydrogen and nitrogen, they are very, very they're very near. So I am very lucky. I'm getting the same answer as if it was 1, 4, and 1. So I'm getting the same answer as if it was nitrogen. So I got the same answer. CH4N. CH4N is B again. It goes for B again. Question number 26 is B. Question number 26 is B. I got it again. B. All B. Please don't do that in the exam. An organic compound contains these, and these. Chlorine by mass. What is the empirical formula of the compound? Of course, this is easy. We can't continue to do this. This is easy. You should be able to solve this. Try this. Try your hand on this one. If you are unable to solve it, let us know. It's easy. As easy as ABC. And what's the final answer? 27. I did not even mark the answer there because it's so easy. I didn't even bother to solve it. Let's go to 28 now. Question 28. This is one thing I really want you to know. Now, they are telling you complete combustion of 50 cm³ of an hydrocarbon. Remember the equation I gave you. In the combustion of hydrocarbon from your IGCSE video, even from your Edexcel AS video for A2 and for AS, you also have this there. Combustion of hydrocarbon. Every hydrocarbon is CXHY. Every hydrocarbon must have this. Plus X plus Y over 4 O2 to give Y over 2H2O plus XCO2. I hope I'm correct. Plus XCO2. I am 100% correct. Please, this equation is very important. If you can remember this equation always, it would give you no problem when you see this type of thing. That means they say complete combustion of 50 cm³ of these. 50 cm³ of these. Complete combustion. That means no soot. No soot means no black powder. That means everything, all carbon combusted. So, and if all carbon combusted, and they're telling us 350 cm³ of carbon dioxide form, 350 cm³ of this form, we are not bothered about the amount of water form or the amount of oxygen used. Nobody is bothering us about that in this question. They are asking for the formula of the hydrocarbon, as simple as ABC. If this combusts to give this, that means if one of these, we give how many of these? One of these is CX. One of these we give How many of that? X of that. So in this, it's so easy. It's so easy. Our carbon is surely that amount, X. That amount, X. For one molecule, the number of carbon you have there is X. X mole of carbon there. How many mole of carbon is produced there in this carbon dioxide? X mole also. That means if our hydrocarbon was C5 and it's only one here, here also what will be produced? It will also be 5 carbon dioxide. That means C5 will produce 5 volume. Does that make sense? So C5 produce this. So how many? So if you see what we produce that, that means this one divided by this, which is equals to 7. This one divided by this, which is 7. That means this one C7Hy we give in H what? H. We are not interested in the H. We can get the H from the water, but we are not interested in the H. We give us C what? 7CO2. Whatever you have here is what you will have at the back here. So for you to have 350 here, that means by the time you divide 50 by this, you get 7. X here is 7 moles of carbon dioxide. For 7 moles of carbon dioxide to be formed, it has 7 carbon in it. If it is complete combustion, for you to have 7 carbon in it, that means whatever was burning must have carried per molecule 7 carbon C7. Because we are getting ratio 1:7, that means this is 7, and that means whatever is burning here has to be 7. I hope you understand that. If you were looking for hydrogen, you will use water. You will use water, but that is not the question here. So our answer here is C7. C7. So they didn't tell us, and here we only have one C7 here, which is this B again. C7 we only have there is B, which is C7. So I hope you understand that. Let's move on again. Question 29. How many moles of atoms are present in 240 cm³ of carbon dioxide at room temperature and pressure? How many moles of atoms, please? Again, keyword. The keyword there is atom. Please don't forget atom. CO2 is a molecule. Molecule, and it contains what? 3 atoms. 3 atoms. 2 of oxygen and 1 of carbon. So if we use these 24 dm³ and 24 cm³ to get the number of molecule of carbon dioxide that is present, we multiply it by 3 to get the number of atoms, mole of atoms. So we know that N of molecule of carbon dioxide equals to 240 divided by 24,000. 1, 2, 3, sorry. 1, 1, and we have 24 here, 1, 24 here, gone. So 1 over 100 is 0.01. 0.01 there. 0.01 is the number of molecule. There is 1 molecule here. So how many atoms in 1 molecule? 3. So that means there's 0.01 molecule here. 0.01 molecule. 0.01 molecule. So how many atoms will be there? This will be 0.01. This will be 0.01, 0.01. 3 of them. So your N for the atom will be equal to 0.01 multiplied by 3, which is 0.03. You have come across these moles of atoms. Moles of atoms. D. We are moving away from B. D. Number 29 is D. We got that correctly. Let's move to number 30. What is the percentage by mass of nitrogen in ammonium nitrate? When you calculate very well, 14 plus 14, 28, 28 plus 48, 28, 48, this is equals to 74 plus 76 plus 4, which is 80. So that is 80. that is 80. That's the MR of that is 80, and they are looking for what? Percentage by mass of nitrogen. How much nitrogen do you have there? Of course, 2 of it, which is 14, that's 28. 28 divided by 80 is what they are asking us. Make it into a percent. So 28 divided by 80 equals to times 100. Answer 35%. 35%. D again, good. 30, we are moving away from B. D. Question number 30 is D. Correct. D. Correct. 31. Which of the following can be determined for an unknown alkene using only percentage composition by only percentage composition by mass? You don't need to be told. Even a blind man knows this. I'm sorry, I'm not insulting the blind people. Many of them are very intelligent and they get first class in the university. They get A star in their exam, in their A-level exam. No matter what, this is very easy for any student in A-level. Even IGCSE student. Percentage composition by mass. Is it molecular formula? No. For you to get molecular formula, you need the empirical formula and molecular mass. Empirical formula, of course, this is the only thing you need. But let's go further. Both the molecular formula and empirical formula, no. You need 2 things to know this, but this you only need 1 thing, so we can't say both. Structural formula, of course, not this. So my answer will still be the simplest formula or empirical formula. I need the percentage by mass. Data number 31. You see the teacher always checking if the simplest one is checking. So B again. Yes, so that because nobody is Mr. Know-All. Teacher makes mistake. The teacher can make mistakes sometimes, so it is not something you say, oh, teacher make a mistake. Of course, we are human beings. Let's go. Which of the following gas sample occupies the greatest volume at the same temperature and pressure? Of course, ethane. Ethane is C2H6. C2H6, which is 24 plus 6, which is 30. So 1 mole of ethane, 1 gram of ethane, the number of mole is mass divided by molar mass, which is 1/30. Okay, 1 gram of oxygen. M is 1 gram of oxygen, 1 divided by MR of oxygen. Oxygen is O2, so it's 32. 1 gram of fluorine is 19, so 38. Because it has to be F2. It's diatomic. It has to be F2. So 1/38. And 1 gram of neon. Neon is 20. Neon is 20 and its monoatomic is Ne. Neon is 20, so this is 1/20. Please, you can check in case your teacher is making a mistake. Check from your periodic table. 1 gram of neon is 1/20. So when you look at all these, they are looking for the what? The sample that has the greatest volume. For you to get the volume at same temperature and pressure, let's even assume it's at RTP or STP. So that means at RTP, we say volume is equals to what? Is equals to, because number of mole is equals to volume divided by 24,000 if it is cm cube. So volume equals to N multiplied by 24,000 cm cube. So which one, the one that has the biggest N will be the one that has the highest volume. Which one has biggest S here? The one that has the biggest N here will be the one with the smallest denominator, because the denominator is 111. So this is the one that has the highest volume because it's having the highest N. The N here is the largest because it has the smallest denominator. So our answer is D. Let's check 32. If it is D, we are also correct. It is D. Let's continue. 33. Now we are moving. We'll soon finish. Hydrogen peroxide decomposes on eating as follows. This is hydrogen peroxide again. What is the mass of hydrogen peroxide required for 16 grams of oxygen to be formed? Now, it's again ratio 2:1. When hydrogen peroxide decomposes, it forms 2 mole of water and 1 mole of oxygen. So they are now telling us if we don't want 1 mole of oxygen, we want only 16 grams of oxygen to be produced. And of course, 16 grams of oxygen is mass 16 divided by molar mass of oxygen. Don't forget oxygen is O2. That is the amount of oxygen that is present in 1 unit molecule of oxygen because it's diatomic. 32. So it is 0.5 moles. That will be, they're asking us what mass of hydrogen peroxide required to give this. So 0.5 mole of this is what we want. When we had 1 in the equation, 2 produced it. If you want 0.5 mole of it, only 1 mole of this will produce it. What is the mass of 1 mole of hydrogen peroxide? The mass of 1 mole of hydrogen peroxide is H2O2, which is now 32 plus 2 plus 32, which is 34. C, the first C here, 33, C. 33 is C. 33 is C, correct. We had 33 in 34, sorry, 34 is C. 34 is C. Now let's go. Question number 34 now. 34, how many moles of ions are present in ions? Please, these calcium chloride. Don't forget, calcium chloride is 1 calcium ion and 2 Cl minus. It already has how many ions? 3 ions. 1 calcium ion and 2 chloride ions. Put that one here because they are asking of ions. Many students will miss it because of this small things in the equation. How many moles of ions are present in 20 cm cube of this? Let's first calculate how many calcium chloride we have. How much of calcium chloride and N of calcium chloride is equals to, okay, concentration multiplied by volume in dm cube, or just divide by 1000 directly, which is the same thing. So this is equals to this concentration 0.05 multiplied by 20 divided by 1000. Here 1, here 5. So N is equals to 0.05 divided by 50. 0.05 divided by 50. 0.05 divided by 50 equals to 0.01 mole. 0.01 mole is what? 0.001 is what we got, mole of the whole compound. So that's 0.001 mole, but it has 3 ions. So how many moles of ion we get? The same thing. That means 3 times 0.001, which is equal to 0.003, because each one is supposed to have 3 ions. So 0.001 mole, we have 0.001 multiplied by 3 number of ions. So that is 0.003. Again, B, mashallah. Look at B again all the time. B again. Question number 35. Now we're almost finishing. The definition of mole is this. You have been tricked in this question. You have to be very careful. This question is a trick one. The amount of any substance which occupies the volume of this. Many students will shoot that straight, because they have seen occupies the volume of this. No, because they say any substance. No, for it to be this, it has to be the amount of gas. How many molecules of gas we occupy that? So that is wrong, because they are not saying gas, they say any substance. The amount of any substance containing the same number of identical entity as the amount of the substance in this one is telling us the meaning of what? MR. All this is telling us the amount of any substance which is contained in the MR or MA, depending on if it is what? If it is the molecule. If it is a what? If it is atom, that is the unit. So same is the same thing as relative atomic. Same number of identical entity as there are in exactly 12 days of carbon. Correct. But let's continue. We may be tricked. The number of atoms in exactly 12 grams of carbon. We are not talking about carbon alone. It will be correct if they are said 1 mole of carbon is the definition of mole of carbon. But we are not talking about carbon. We are talking about general. So this can be correct. The number of molecules in exactly 2 grams of hydrogen. This is only for hydrogen. But we are talking general. This, it can be correct. and hydrogen is not our standard here, so this can be correct. Carbon is our standard, but we are talking about only carbon here. Even hydrogen here, this will have been corrected. It will have been correct if they put hydrogen here. But so the amount of any substance contained in the world, the MR of Cl2 is 70 what? This is 35.5 times 2, which is 71. Which is 71. That's the MR. That is the number of the mole of chlorine. 1 mole of chlorine is the amount of chlorine which is present, the amount of what? Chlorine molecule present in 71 grams. You understand? Because of this. So let's continue. That is the correct answer. Number B is the correct answer. And let's go. Number B again is the correct answer. B. Any student giving this exam and he has all his answers to be B will be a very lucky student. Be a very lucky student. Let's go on. A sample of gas was prepared for use in helium neon laser. It contains 4 grams of helium and 4 grams of neon. What is the ratio of helium atoms to neon atoms? Helium atoms, the ratio of helium atoms to neon atoms. Number of atoms of helium to that of these. So if we get now sample of what is the number of mole of helium first. Helium N equals to mass times molar mass, which is equals to 4 grams divided by helium is also 4, so this is equals to 1. And neon, okay, neon, 4 grams of neon also, 4 grams of neon for neon, N equals to M over MR, which is equals to 4 divided by what? 4 divided by 20. 4 divided by 20 is 0.2. We have 1 mole of helium and how many moles of, we have 1 mole of helium and 0.2 mole of neon. So the number here of atoms here will be 1 times 6 times 10 raised to power 23 atoms, and this will be 0.2 times 6 times 10 raised to power 23 atoms. So of course we don't need this because they already go. So 1 divided by this is 5, so that means 5 is to 1. 5 is to 1, which is D. 5 is to 1. 1 divided by 0.2 is 5. So 5 is to 1. Look at 1 to 5 here is here. You have to be very careful. That's why I wrote this first. Helium to neon is what they are asking us. So that's why I wrote this one first, so that we don't make a mistake, because I know they will change it like this. And students will just pick one if they didn't write this one first. Let's go number 38 now. Let's go. What is the number of atom in 2.8 grams of ethane? Number of atom in one mole of ethane already is how many atoms? How many atoms? 2 of this and 4 of these 6 atoms. Whatever mole we get, we multiply by 6. 2.8 grams of ethane, 2.8, which is N equals to M over MR, which is equals to N mass is 2.8. Ethene is C2H4, which is 24 plus 4, which is 28. Divided by 28, and this gives me 0.1 mole. 0.1 mole is what I have here, 0.1 mole. So in one I have, so what is the number in 2.8 gram ethane? What is the number of atoms? So the number of atoms here is 0.1 multiplied by what? Multiplied by 6 times 10 raised to power 23. Let's assume that, because it has been given to us 6 times 10 raised to power 23. That is the amount of this. But each of it, 6 atoms. So it is atom we are looking for. This is the number of molecule, number of these. Number of molecule is this, because this is the mole. The mole, this is the number of molecule of C4H5. Number of atom will be multiplied by another 6, because in this one, in each of these 6 atoms we have there, our answer will be 3.6 multiplied by 10 raised to power 23. So 3.6 multiplied by 10 raised to power 23 is our answer D. Number 38, are we correct? Yes, again we are. Number 38. Number 38. We didn't do 36. Did we do 36? 37. Okay, 38. 38. Okay, we are correct. We are correct. 38. We are correct. 38. 39. I think a sample of swimming pool water contains this per million, part per million of chlorine. This is equal to percentage of what? A sample of swimming pool contains this part per million of chlorine. This is equal to what percentage? The part per million is this. So 0.482 divided by what? 1 million. That's part per million of this. Part per million. So this is this part per million. This part per million means this, okay, of chlorine. They are looking for percentage. Multiply by 100. This by this by this by this, and that's the answer. Because they are looking for percentage. They want me to take that part per million to percentage. That's just mathematics. So I know this part in per million. So if you watch the video very well on my part per million, on my atom economy and all these, my videos on moles and all quantitative chemistry, my videos on quantitative chemistry, all this will be very easy for you. Go to the website, you watch the videos on quantitative chemistry and you will have no problem. So this now means 1, 2, 3, 4. I have to move these 0 4 places. So 0.482 4 places. 1, 2, 3, 4. 0.12345. 0.1234. No, 1, 2, 3, 4, 5. 8 has to be C. Number 39 has to be C. 1, 2, 3, 4, 5. 5. Because I have to move that 0 4 places. 1, 2, 3, 4 places. How many places? 1, 2, 3, 4 places. Sorry, I have to move that 4 places. If I'm moving that 4 places, it means 1, 2, 3, 4 means 0.482. Don't let me make mistake. 1, yes. 2, yeah. 3, yeah. 4 places here. 1, 2, 3, 4, 5. 5. It's C. C is my answer for question number 39. C is my answer for question number 39. 1, 2, 3, 4, 5 places. 0.4 C. Let me check again. Now I'm using this shortcut. Let me use the calculator. I'm getting different answer from the answer right there I got before. 0.48 divided by 1 million times 100. 0.48 multiplied by 100. 0.482. 0.482 multiplied by 100 equals to divide by 1, 1, 2, 3, 4, 5, 6 equals to 1, 2, 3, 4, 5. 1, 2, 3, 4, 4. Teacher was making a mistake. The answer again is B. Teacher was making a mistake. The answer again is B. So you always have to cross check with your calculator. I was using our old method. 1, 2, 3, 4. Okay. So now 1, 2, 3, 4. So 1, 2, 3, 4. I was moving in 5 places. Now that is our answer. 39 is B. There's a question I didn't see about lead. I saw there was a question that's supposed to come about lead. Phosphorus, sorry, and phosphorus. This question I didn't solve. Question number 36. 1.04 grams of phosphorus pentachloride molar mass. This is reacted completely with water and the solution made up to 1 dm cube. Solution made up to 1 dm cube. That means the volume of whatever is present is taken to be 1 dm cube. Each of them. Now they are now asking the concentration of hydrochloric acid in mole per dm cube is what? So we are given this amount of phosphorus. Okay, that's the molar mass, and it reacted completely. Then how much of this phosphorus pentachloride is in this? So that means N equals to M over MR, which is equals to 1.04 divided by 208. This is the amount of mole we have. 1.04 divided by 208 equals to 0.05 mole. 0.05 moles. 0.05 moles of this is present. So 0.05 gives me how many of HCl? 0.05 multiplied by 5. 0.05 multiplied by 5, that's 0.25. 0.05 times 5 equals to 0.025. 0.025 moles of this will be produced. 0.025 moles of that will be produced. How many? So you are looking for the concentration of hydrochloric acid in mole per dm cube. That's at the end of the reaction now. Hydrochloric acid equals concentration in mole per dm cube. Concentration in mole per dm cube equals to number of mole divided by volume in dm cube. So the number of mole is what? Number of mole is 0.05 divided by 0.25. 0.025 divided by 1. So our answer is 0.025. C. 0.025 is our answer. 36 is what? 36, question number 36, 0.025 is our answer, because volume is 1 dm cube. So that is the end of this video. We have solved up till question number 39. We solved in the 2 videos. I have solved 40 questions for you out of the 60 questions I have in the worksheet for you. 60 multiple questions on moles and all this quantitative chemistry. I know you usually make mistake when they say 1 atom, when they say mole. All these little things cause problem for you. I'll continue to solve the multiple questions because for the Edexcel chemistry, the headache of students is the multiple choice, and the theory you can handle it if you understand the multiple choice clearly. So now, students, this is the end of this video. I'm going to leave the remaining 20 questions for you to answer. The remaining questions in the worksheet, I'm supposed to do the 3rd video, but I'm not going to do it. So handle the remaining 20 questions yourself, and I'm sure you will have fun. Should you have any problem, you know the normal thing on my website. Do not hesitate. Send your email and the teacher will respond to you with another short video within 24 hours. A short video custom made for you will be sent to you by Teacher Afeez within 24 hours should you have a doubt in any of the videos or any of the questions you are solving. So students, good day and God bless.